break. We'll do a little more. We'll see how we're feeling. So our main goal today is just, we're thinking about simplifying, multiplying, and dividing rationals. A lot of it, we're just doing a lot of factoring. The main goal is just canceling out common factors. That's not bad. So yesterday we had done 3A. Did we do 3A?
Yeah.
Okay, I can't remember what class does what. I'm losing my mind. We're gonna do 3B. We're gonna skip that little word problem for now. I know it's not on like an assessment or anything, so I'd rather spend a little more time just practicing problems. And we will do the complex ones. So we'll do that stuff and we'll take a little break. So I look at a problem. I say, organize myself first. I don't really care what you do. I'm gonna factor it first and then flip it, just because there's something I wanted to show you in a second. So I'm just gonna start by doing that. Factor. That would give me what? X plus 4, x plus 1. So these factorings aren't that bad. The warm-up sheet, they're a little bit more complicated, but this would give me what? X plus 4, x minus 3. We're dividing it by, that's a difference of 2 squares, our good old friend. X plus 1, x minus 1. And then that's just a GCF problem, right? There's not much else I can do. GCF of 2x, and I would be left with x minus 3. Okay. So with that set up, now I see it's a division problem. So I know it's kind of annoying because I'm going to have to rewrite it and flip it. But there's something I wanted to point out about the denominator in a second. So I am going to rewrite this as my first fraction. Change it to multiplication, flip my second fraction. Because that's how we divide fraction back in the day. Okay. And now I can start to see, is there anything I can cancel? Are there common factors that would reduce to just be 1? So x plus 4, anything over itself, we can kind of cancel out because once again, it technically changes to a 1, which we don't need to write. X plus 1, x minus 3, and we're left with 2x over x minus 1. That wasn't that bad. That's very satisfying when things start canceling. We do need to write domain restrictions. Remember, the big thing with fractions is we never want a 0 in the denominator. So we're going to say x cannot equal. So remember, it's any time during the problem. So with this, the division problem, and then you kind of flipped it, so then there's different things in the denominator, so you have to take everything into account. So I'll go through here. So this can't be negative 4, right? Because if I set that equal to 0, I have to subtract 4. Positive 3. If I just have an x, like a 2x, that means x can't equal 0, okay? Because if I say 2x cannot equal 0, and I just divide it by 2, that's x cannot equal 0. That's where that 0 is coming from. 3 we had already written, so you only need to write it once, you don't have to write it twice. And then I flipped this, so then we have to go to this part as well, so it's kind of a pain, because you have to kind of check 2 parts. But if anywhere in the problem it's in the denominator, you have to take it into account. So those 2 we already accounted for, but we could also say a negative 1 and positive 1 also could not, x could not equal those. Oh, so all sorts of fun stuff going on. But the main thing you do have to remember is just anywhere during the problem, look at your denominators, and it doesn't matter what part it is, if not equal 0. So the denominator can never equal 0, so just be careful. I don't know where I am here. Sorry, I have pages everywhere. Okay, beautiful. So, that's kind of nice because once again, same general steps as we were talking about yesterday. You just need to remember when you see the division to flip and change it to multiplication. So, we are going to skip the little word problem. We can go back later. I know it's not on your thing, so I'm not going to waste like 10 minutes doing it at this point. We have some that say multiply, divide. I'm going to have you guys try those in a minute. I just want to show you the complex fraction. The challenge ones are actually not as challenging as they look. It's really just about setup. So I'm going to show you A, and then I'm going to have you do that multiply, divide, and the complex fraction. We'll wrap that up. And go from there. So I'm on example 6A. It says complex fractions challenge. How exciting. Divide, stating restrictions. I feel like people just a lot of times freak out when they see a fraction over a fraction. What I do at this point, this is really not a challenge, that's a lie. You just rewrite it. You're gonna write it as 8x squared y over x plus 1. All you're gonna do is instead of writing a division bar, you're just gonna write a division symbol. That's all that means, right? And then we're gonna write that as 6xy squared over x plus 1. So once again, the challenge is really just like, oh, don't get freaked out by the setup. It's really just a division problem. So if you rewrite it, it looks a lot nicer. So from here, since it is division, I'm going to keep the first fraction the same. I'm going to change it to multiplication. I'm going to flip the second fraction. And I'm going to start to reduce. I see the x plus 1s are going to cancel, so I'm just going to start with that. The other ones, I'm going to kind of just simplify, reduce, do whatever I can. So I notice that 8 over 6, those are both just divisible by 2, right? So that would turn out to be 4 over 3. If I have x squared over x, that means I have 2 on the top, 1 on the bottom. 1 cancels out, so that would just end up with x. And if I have 1 on the top, 2 on the bottom for the y's, one of them cancels out, so that will leave me with y on the bottom. So all I'm left with is 4x over 3y. So the work was no different than what we've been doing, whether you're simplifying and just kind of canceling or you're reducing. So let's write our restrictions, because we always are going to do that. Sometimes there isn't any. I guess if there's no variables in the denominator. So let's just think about life. I'm just going to kind of start here. So this x can't equal -1. Okay. That's the same, so you don't need to write it twice. That's the same, okay. So then the only other denominator we have to really deal with is this one. So we would also say x can't equal, since there's just that x there, x can't equal 0 either. And once again, if I threw a 0 in here, that would change the whole denominator to 0. And we also have that variable of y, so you would also say y cannot equal 0. So if you have binomials, 2 terms, you're kind of just doing a quick solve. So subtracting 1. If you just have like a variable with no addition or subtraction, so it's just kind of multiplication, you just say that that can't equal 0, because then that would change the whole thing to 0. So that's that. So don't get freaked out when you see a fraction over a fraction, you just rewrite it. Just a fancy way. So I wanted to give you guys a few minutes, because I feel like sometimes I just like rush through and you don't actually get to practice to see if you know what you're doing. So why don't you try example 5 has 1 multiplication, 1 division. So if you saw that, would you know how to go about it? How do you feel? Making sure when you're canceling things, they do have to be exactly the same. I'm going to that after. And then if you have time, I'll give you a few minutes. Try 6b. So another complex fraction. Once again, just going through the setup. So I'll give you a few. I'll even like in a minute, I'll kind of check them with people, but always feel free to just kind of shout out to me, call me over. What is going on with my screen? That's different. I'm just gonna play video. But I just wanted to try a few and see how you're feeling, and then we can check and see if we're on the same page, and if not, we can clear anything up today. So I just started and I'm saying, well, nothing's canceling right now for A, so I'm gonna start to factor. That's always kind of your key here. So that would be what, x plus 5, x minus 2. Over x plus 6, x minus 2, times, that's just a GCF, so that's 3, that would be x plus 6, and that would be x plus 3. Okay, So we're all set, and let's just see what happens. These cancel, that's it. So my final answer would just be x plus 5 over x plus 3. Domain restrictions, I'm just writing dr because I'm getting lazy. X cannot equal negative 6, is that a minus, positive 2, and negative 3. So I just basically go for every binomial. Oh my god, what did I do wrong? Oh, there should be a 3 on the top. Thank you. I knew it when I saw it. Thank you, lost it.
You wouldn't multiply?
No, you can just leave it like that. So I think on the assessment, I said leave it in factored form. So that means you don't need to like go back and multiply things out.
So it doesn't need to be like 3x plus 15?
No. Okay, so besides me just writing the answer wrong, were there any other questions on that one? Yes, go ahead, you have a question.
Oh wait, no, never mind. No, I didn't.
Okay, beautiful. Okay, so the big thing with this one, I'm gonna start to factor b, but the big thing was that second numerator, so you just have to be careful with the little tiny things. So what's this, x minus 5, x minus 2, x minus 5, x minus 3. So I'm not gonna factor this yet, I'm just gonna rearrange it, I'm gonna arrange it to negative x squared plus 4, which doesn't really help me because I can't factor that. But I notice I always want my leading coefficient to be positive, and then if I divide out that negative 1 as just like a common factor, it will be a difference of 2 squares. So if I divide out negative 1, it's now x squared minus 4, and I can factor that. How exciting. We have negative 1, and then that would factor to x plus 2, x minus 2. So I tried to give you a little hint on that one. But sometimes when you come across something, if that obviously doesn't look nice, it's not in standard form, rearrange, you can always change signs by just dividing out a negative 1, so little things like that. This will be what, x plus 6, x minus 3. I just wrote that whole thing out, now I'm going to be annoyed because I have to rewrite it all back out. Oh gosh. So these get a little bit annoying because I have to flip it. Change it to multiplication and flip. Oh my goodness, my arm's falling off, but that's okay. So we start to look, cancels or just reduces to 1. Cancels. That's it, right? So x plus 6 over negative 1 times x plus 2 would be your final answer. If you had written negative x minus 2, that's fine. But when I usually say factored form, that means you just like leave it with the parentheses. You don't need to do anything too fancy. And then we'll do the domain restrictions. X cannot equal 5, 3, negative 6, negative 2, or 2. Oh my goodness. So remember, you check everything. So you have to even go back to that original. So that's kind of annoying, but it's a pretty quick step. It's just you need to remember to do it. It's that deal. So that's that. Does anyone have a question on A or B? Yes.
So like for B, would it be wrong if I wrote like the bottom half as a negative 2 minus x?
No. It's not wrong. Sorry, that was just like such a weird reaction for me. I'm just thinking in my head. But yeah, it's just an extra step that you don't need to do. So don't feel like you have to distribute back in. You don't have to. Okay, let me do that last complex one and then we'll take our break. So this was number 6, a B. If you got to a grade, if you were kind of just working on it or kind of gotten there, that's also perfectly fine. But we might as well go over it because we got it. So I'm gonna rewrite it. I'm gonna do a lot of rewriting on this one. X squared minus 1 over x squared minus 9. I'm reminding myself that's just a division problem. So I'm just gonna write this divided by x squared plus 3x minus 4 over x squared plus 8x plus 15. I'm gonna factor it. We have some difference in 2 squares. That's a delight. I always like those ones. They're always quick. I'll just have that divided by. And then this would be what? X plus 4x minus 1. X plus 5, x plus 3. Now here's where my arm really falls off because I need to rewrite this whole thing. I can do a little shortcuts, go for it, but I'm just trying to show you everything that I'm doing. I need to change that to multiplication and flip it. Okay, so when I start, those would cancel. These would cancel. Is that it? Yeah. That's it. So my final answer would be x plus 1, x plus 5. Once again, don't distribute that out. Just leave it like that. Don't do more work than you have to do. If I say in factor form, that's how it should say. Over x minus 3, x plus 4. That's your final answer. There's nothing else we can do to simplify. There's nothing else that's going to reduce or do anything from there. We just need to write our domain restrictions. X cannot equal 3, negative 3, negative 4, 1, negative 5. I think that's it, right? Oh my goodness gracious. So when you see a complex fraction, it's really just a division problem. So it's just recognizing that's. Are there any questions on the ones that you guys just tried? So I wanted you to kind of try and see if you were feeling okay. Anything that you want to clear up? Okay. So let's